Lesson 3.4, solving inequalities using addition or subtraction. So before we get into this, we have to understand what an inequality is. An inequality is similar to an equation, except instead of equal sign, there will be either greater than, or equal to, less than, or less than to equal to signs. Something such as y plus 5 is less than 6. So here we see that this is like an equation, right? You have an expression and an expression, except instead of an equal sign, you have this sign. So the way I like to think about it is, think of it like an alligator. This is like the mouth of an alligator. The alligator always wants to eat the bigger side. So since this is saying that 6, whatever's on this side is bigger than this. This is saying that whatever's on this side is bigger than this. But in reality, in math, we just like to say this is less than. Y plus 5 is less than 6. Something like, if it had like this line under it, it would be less than or equal to 6. If it was like this, it would be y plus 5 is greater than 6. If it was like this, then it would be y plus 5 is greater than or equal to 6. So how would you solve it? Just like you solve an equation. So here you would subtract 5 from each side, minus 5. This brings you to the solution to an inequality. Y is less than 6 minus 5, 1. Y is less than 1. The solution to an inequality with the variable is the set of all numbers that produce true statements when substituted for the variable. So in order for y plus 5 to be less than 6, y must be less than 1. That's the solution to the inequality. So if we have this here, we have this here. Now, x is less than a. This means that x is less than a. This means that x is greater than a. This means that x is less than or equal to a. X is less than or equal to a. This one means x is greater than or equal to a. Now, x is less than a, we express it with an open circle because since it can't be equal to a, the a isn't really included. We just have to make sure that we say that everything in the negative direction is included because x has to be less than a. For number 2, x is greater than a. Again, it's still an open circle because we're not including a, but x has to be greater than a, so we point in the positive direction. For number 3 is x is less than or equal to a. In this one, it's a full point, not like it's fully shaded because it includes a, because x can be equal to a, but it's less than or equal to, so it's less than or equal to. And number 4, x is greater than or equal to a. So here we see that x is greater than or equal to a. This brings us to example 1. Example 1 says that the freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid ice. Write an inequality that gives the temperatures at which water is solid, then graph the inequality. So if for water to be frozen, the temperature needs to be 0 degrees or less than 0. So x has to be less than or equal to 0 degrees Celsius. Because it could be 0 degrees Celsius because it's going to be frozen at 0 degrees Celsius, but it's also going to be frozen at everything less than it. So we would graph this on a graph, a line graph, as x is less than or equal to 0 degrees Celsius. So if this is 0 degrees Celsius, we're going to have x is less than or equal to, or less than. This is what it would look like graphed. So, and x equals temperature in degrees Celsius. So that's example 1. That's a very simple example. It's just showing how you could apply this when we're talking about math. So you can use the following properties to find the solutions of inequalities involving addition and subtraction. Using these properties, you can write equivalent inequalities. That may sound familiar just because we just talked about equivalent equations. So in order to maintain an equivalent inequality, you have to use these addition and subtraction properties of inequality. So these are the properties, which is, you're going to see how similar it is to the equation properties. Adding, the only ones that are different are the multiplication and division, but that's next lesson. Adding or subtracting the same number on each side of an inequality produces an equivalent inequality. This is very similar to what we learned about with equations, because you could add and subtract on both sides and you maintain an equivalent equation. This is, you can add or subtract on both sides the same number and you could maintain an equivalent inequality. It's the same rule. It gets a little more complicated next lesson, but we'll worry about that then. This brings us to example 2. Example 2 says, we have to solve m plus 5 is greater than or equal to 10. So if m plus 5 is, we have to treat this like an equation. So we have to isolate m. So we have to subtract 5. So m plus 5 minus 5 is m is greater than or equal to, bring the same sign, 10 minus 5, which is 5. So m has to be greater than or equal to 5. And we would graph this on a number line by doing if this is 5, f is greater than or equal to. So greater than or equal to 5. We pointed in the positive direction. So, and you could test if this is true by plugging in 5 or plugging in anything above 5. So you could plug in 6. So let's test it out. Check. This is where we're checking our solution. So if we plug in 7 is above 5, so it's technically a solution. So let's plug in 7. 7 plus 5 is greater than or equal to 10. Is 12 greater than or equal to 10? Yes, so it is. And we could plug in 5, and we're going to see if 5 plus 5, 10 is greater than or equal to 10. It is. So those are ways that we could double check our solutions. This brings us to example 3. Example 3 says solve negative 10 is greater than x minus 12. So we have to isolate x. So this is x plus negative 12. So we have to add 12 to both sides. So this is going to be x alone. X is less, x is x here, and then negative 10 plus 12 is going to be 2. So remember how I said that we like to have the variable on the other side of the equation? In this case, since if we want to put it here, like this does not equal x is greater than 2, because we can't just switch the sides without switching the sign, because if 2 is greater than x is not going to be greater than 2. What we do is if we switch sides, if we switch sides, sign must flip. Let's put this in blue because it's very important. So this does not work if we wanted to put x over here, we have to put x is less than 2 because we're flipping the sign. If we're flipping the whole thing, we have to flip the whole thing. It's a better way of understanding it. Because if 2 is greater than x, x has to be less than 2. It only makes sense. X can't be greater than 2 if 2 is greater than x. It doesn't work. This is all of example 3.